This is Algebra 2, Lesson 8.5, Permutations and Probability. The counting principle says that if you want to count the number of ways to do something, and you have n ways to do one thing, and n ways to do something else, and n ways to do something else, basically you just keep multiplying them all together, and that would show you how many ways there is to do all of those things. Factorial looks like an exclamation point. Factorial is a number multiplied by the next lowest number, multiplied by the next lowest number, and the next lowest number, and the next lowest number, all the way down to 1. So for example, 4 factorial would be 4 times 3 times 2 times 1. And 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Permutation is like that. It has a number, a p, and another number. There's a big fancy formula for it, but I think easier is the n represents the first or the starting number, and the r represents how many numbers. So if I wanted to do 10p4, I would start at 10 and count down just like I did with the factorial, but I wouldn't go all the way down to 1. I would just stop after 4 numbers. So in a sense, a number factorial is the same as NPN, where you're starting at the number it tells you to start at, and you use all of the numbers. I'll do one more. How about 50? Well, that was a big 0. P3 would be 50 times 49 times 48. So the number to start with, how many numbers you use, count down. The question always comes up, when do I use the counting principle versus when do I use permutations? Now they're really the same thing, but a permutation would be like you're using something up. You're not replacing it, so you can't choose it again. It's no longer a choice. Let's do some examples, and hopefully that's a little clearer. Example A, suppose a license plate has any of the three letters followed by any 3 numbers. How many different plates are possible? So just a couple examples would be like a APD796 or PFF929 or ZXQ333. We get the idea? If I had to write out every single possible license plate, how many are there? So I'm going to look at my scheme of things. I have 3 letters and 3 numbers. And if I want to know how many are possible, my counting principle tells me to multiply how many choices for this spot, and how many choices for this spot, and how many for this, and this, and this, and this. Multiply those all together, and that will tell me how many there are possible. So this first spot can be any letter of the alphabet. There are 26 letters in the alphabet. And the next spot can be, again, any letter in the alphabet. Oh, there's 26 more. And another any letter, 26 more. And the next spot can be any digit, 0 through 9. That is 10 numbers. Don't forget to count 0. And again, any digit, and again, any digit. So I will multiply these all together. 26 times 26 times 26 times 10 times 10 times 10, 17576000. So there are over 17 million possible license plates. To list those all out would take quite a while. Example B, what is the probability that a license plate has no repeated letters or numbers? So this is going to follow more of that permutation scheme. of the examples that I listed, this one wouldn't be possible because it repeated the 3. And this one wouldn't be possible. It repeated the F's and it repeated the 9's. So we're going to eliminate a lot of those possibilities. So I'm going to go back to my original scheme. I have 3 letters, 3 numbers. If I can choose any letter of the alphabet for this first spot, there are 26 letters to choose from. But now that I've chosen a letter, any letter I want, let's say I chose the letter A, I no longer have that letter as an option in this blank. So now there's only 25 possible letters. I've used up one. I've used up another one in the second spot, so now I only have 24 possible letters. Now I'm switching to my numbers. 0 through 9, I have 10 choices. I used up any one of those. If I used up the 7, now I only have 9 left to choose from. I say I used up the 5, now I only have 8 left to choose from. So really this is 26p3 times 10p3. Multiply these all together. 26 times 25 times 24 times 10 times 9 times 8. I have 1, 1, 2, 3, 2, 0, 0, 0. So out of my 17.5 million possible license plates, I've eliminated almost 6,000 because now I only have 11 million, wow, millions, and we have 11 million possible license plates. So this question doesn't say how many are there, it says what's the probability. So the probability then would be that same number, 11,232,000, out of the original 17,576,000. Scrolling down. 7 flute players are performing in an ensemble. The names of all 7 players are listed in the program in random order. What is the probability that the names are in alphabetical order? 7 flute players means I have 7 names, and I need to use all 7 names. So I got one name, and then another name, and then another name, and then another name. I'm counting down because I'm never going to reuse somebody's name. I use a different name every single time. I'm not replacing the name into my pool to choose from. So this is really the same as 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. And I get 5,040. So there are 5,040 different ways to arrange 7 names. What's the probability that the names are in alphabetical order? Well, only one of those 5,040 ways is alphabetical order. Every other way would be out of order. How many possible seating arrangements are there if there is a bench with room for only 4 to sit? What is the probability that the group of 4 players is in alphabetical order? So there are only 4 people out of my 7. So I have 4 spaces. Starting at 7, once I've placed a person onto the bench, there's only 6 people left standing. Once I place another person, now there's 5 people. Place my next person. Really what I'm doing here is 7p4. Now the fact that it ends in a 4 is kind of coincidental. It's 7p4 because I used 4 numbers. And that gives me 840. What is the probability that the group of 4 players is sitting in alphabetical order? Okay, so I kind of feel like that question shouldn't be there. If you have 4 people and you want to arrange them in the right order, there are 24 possibilities, so that is 1 out of 24. And I say that question probably kind of shouldn't be there because doesn't really relate to the first part of it, part B. So if it's not there on your worksheet, it's because I might have deleted it. Anyways, last example. How many MP3 playlists are possible if arranging 10 songs from a library of 50? So I have 50 songs to choose from. I'm going to put one song on my playlist, and then I only have 49 left, and then I'm going to put another one, and I have 48 left, and I'm going to put another one, and another one, and I'm going to keep going until I have 10 songs. And that's basically 50p10. So how many playlists can I make then? Using only 10 songs with only 50 to choose from. And I know most people have way more than 50 songs. Yeah, that's a pretty big number. Anyways, that's it for the notes. Sorry, this one's kind of long. Good luck on the exercises. Let me know if you have any questions.